From the previous class, we talked about equilibrium, disequilibrium, and elasticity of demand, whereby we talked about a number of factors. We engaged ourselves in several ups and downs, and then until we were tired, we were exhausted until we called up for another session. So today we are going to talk about elasticity of supply, a very small topic, and we go to the topic of our main concern, production theory. So we are going to take at most 10 minutes talking about elasticity of supply, then we move to the next topic that is of concern. So we can just have a topic or a subtopic under the topic equilibrium, disequilibrium, and elasticity of supply. Then we can talk about elasticity of supply, a very small topic, elasticity of supply, a topic. Then we can just give a simple definition about elasticity of supply, and we can say it is the percentage change. It is the percentage change it's the percentage change of quantity supplied the percentage change of quantity supplied resulting from the percentage change in price. It is the percentage change of quantity supplied resulting from the percentage change in price, and the elasticity of supply is given in this format. It is illustrated in that form. Elasticity of supply is given by change so we are talking about what is supplied with respect to the change in price. Then we are multiplying price over percentage supplied. So that is how we can illustrate the elasticity of supply. And this is QS. This is QS. Then we can talk about determinants of elasticity of supply. Determinants of elasticity of supply. Determinants of elasticity of supply. We can talk about number one. We have at least four. So number one, we have availability. Availability of factors. Availability of factors of production. Availability of factors of production. Availability of factors of production. And you know that factors of production are raw materials. They are raw materials or inputs of producing a given commodity. We are talking about factors of production are raw materials. So we can comment and say, when factors of production are readily available, supply is highly elastic. When factors of production are readily available, supply is highly elastic. Then we can talk about factor number two. Factor number two, we can talk about excess capacity of unsold stock. Excess capacity of unsold stock. We can say if we have a lot of unsold stock, we can easily respond to an increase in supply. I'm saying if we have a lot of unsold stock, we can easily respond to an increase in price by supplying too much. So we said that the producer side, they are profit maximizing. Hence, when the prices increase, they supply more. So we are saying that if we have unsold stock, then we happen that in the market there is an increase in price. So we can easily respond like immediate to that prices and take advantage of the prevailing market condition. Therefore, we can say excess unsold stock make supply elastic. It makes supply elastic. Number three, we talk about time factor. And we can define time here. Define time and say time is the period from which the good is produced and supplied to the market. It's the period from which the good is produced and supplied to the market. So you can say if the time taken is shorter, supply said to be elastic. Supply is said to be elastic. Then number four, finally, you can talk about nature of the commodity. Nature of the commodity. You can say durable goods. Durable goods are highly They are highly elastic in comparison to perishable goods. Durable goods are highly elastic in comparison to perishable goods. Then we can have another subtopic and say applications of the concepts of elasticity. Applications of the concept of elasticity. So we can say number one, it is used in taxation. It is used in taxation. It is used in taxation. So from the previous class, we talked about consumption brought about by habit, such as smoking. Those people are price inelastic. Those goods are considered so the government will consider taxing goods that are inelastic as compared to goods that are elastic. So that is under. So we can give a note, and I want to give an NB and say the government considers taxing goods that are inelastic. Consider taxing things such as cigarette, alcohol, things that people have developed a habit, things that people, they are irresponsive. They don't respond to what they see, they change. Number two, it is important in international trade. It is important in international trade. It is important in international trade. So to encourage exports and discourage imports, that's what the government tries to do. So the government tries, if it has to devalue the currency so that it can increase exports, the exports must be highly elastic. But that is, I want to explain that is beyond this level. Let me hold it at that point. And finally, number three, it tells the relationship between commodities. That is, we can say, that is, it is negative. It is negative. Is negative for complement and the positive is negative for complement and positive for substitutes. Is negative for complements and positive for substitutes. It is negative for complements and positive for substitutes. Okay, now we can move to the topic of the day, the theory of production. The theory, the production theory. The production theory. The production theory. A very interesting topic. It's a very interesting topic, the production theory. So we can have our first subtopic and talk about the basic concepts. Talk about the basic concepts. We need to define some terms before we move ahead. So the first term we are going to define is production. We are going to define production. The first term we are going to define production. And I want to get the concept from your side first before I define production. Guys, help me define production. And to see people streaming in using the public chat area, the definition for production. As according to your understanding, what is production? I've seen what you have given as the production, and we can say, okay, let me have a comprehensive definition for production. All those are production from the English dictionary, Cambridge, all those dictionaries. But you can say production is the creation of goods and services the creation of goods and services. Production is the creation of goods and services through the transformation of inputs, outputs. So that is the definition for production, is the creation of goods and services through the transformation of goods and services. No, it is the production of goods and services through the transformation of inputs to outputs. Hope that is captured clear. So the second term we are supposed to define is inputs. We're supposed to define inputs. We can say they are ingredients. They are ingredients. They are ingredients the farm uses to produce. They are ingredients the farm uses to produce goods and services. They are ingredients the farm uses to produce goods and services. In some books, in some economies, let me use economies, they are called factors of production. They are called factors of production, and they include rand, capital, and labor. They are, in some economies, referred to as factors of production, and they include capital, rand, entrepreneurship, all those. Then number 3, we can talk about output. We can talk about output. And we can say they are the end product. They are the end product of transforming inputs. They are the end products of transforming inputs. They are the end products of transforming inputs. Then number 4, we can talk about the production function. About the production function. We talk about the production function. And we can say it is a mathematical, illustration or expression. Let me use the word expression. Showing the maximum output that can be produced, the maximum output that can be produced given a specific combination, combination of inputs given a specific combination of inputs with the existing level of technology. Given the existing level of technology. So I'm using the presentation area to show that. So you are given Q is equal to F. You're talking about K, L, and R. Then I'm going back to the public chat where Q is output, where Q is output, K is capital, K is capital, L, leper, L is leper, and then R is other input. Other input is other input resources. Whereby Q is output, K is capital, L is labor, R is other input resources. We are defining terms here today. Then we have another term we need to define. That is the short run period. That is term number 5. We have the short run period. Short run period. And we can define it and say it is the period. It is the period in which not all factors of production have changed. Not all factors of production have changed. Then we can have an NB under that and say factors of production that change within the short run period, are variable inputs. The factors of production that change within the short run period are variable inputs, and the factors of production that do not change in the short run period, are fixed inputs. They are fixed inputs. Then we can talk about another thing, number 6. We talk about long run period. And we can say It is a duration. A duration when all factors of production have changed. It's a duration when all factors of production have changed. Then we can have an NB and say in the production process, labor is assumed to be a variable input, while capital is assumed to be a fixed input. In the production process, labor is assumed to be a variable input, while capital is assumed to be a fixed input. Then the last term we are supposed to define, number 7, we are supposed to know what are isoquants. For those who read the objectives before they logged in, they are what we call isoquants. We can say it is a curve. It's a curve that shows. It is a curve that shows all the combinations. That shows all the combinations. That will produce a certain level of output. That will produce a certain level of output given the same level, of technology. This is a curve that shows all the combinations that will produce a certain level of output given the same level of technology. Guys, are we there? Are we there? Ma tulilog in tukaenda nyumbani. And to see these people logged in and went home. All right. So those are the basic definitions we need to understand. There's no better way I can explain a definition. There is no better way I can explain a definition. But today we want to discuss some key things before the day falls. So let us have a subtopic and talk about types of production curves. 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 And number 1, we can talk about total product curve. Total product curve. Total product curve. And we can just say in simple terms, because total product curve, we have variable and fixed input, and we are said in the short run we have labor and capital to be considered. One is considered variable, another one is considered fixed. So when you talk about Rob, so I'm saying we have to introduce total product curve in this manner. You have to introduce it in this manner, and we can say in the short run, the total product curve shows the maximum output obtainable from different amount of variable input given specified amount of fixed input. So the total product curve in the short run, it shows the total maximum output, or it shows the maximum output obtainable from different amount of variable input given specified amount of fixed. What? The same mistake? Given the same amount of fixed input. Given the same amount of fixed input, we can illustrate that graphically and talk about it being in this way. We are talking about the total product curve. The total product curve we have in the, because we said labor is the one that is variable, we have labor in the x-axis. Then we have the total product curve. Then we have the origin here. So when we talk about the total product curve, it is illustrated in this manner. Make sure your curve is smooth because you are at comfort of what you are doing. So this is what we call the total product curve. It is given in that manner, but it is supposed to be smooth. Then it curves at the other end. So that is the total product curve. That is the total product curve. So that is the total product curve. The total product curve is given that. And in the short run, because we are talking about the short run period, the total product curve is sometimes indicate I'm saying in the short run, because we know that there are factors that are fixed, so it is given by the total product curve is indicated in that manner. And we said capital is the one that is normally fixed, so that's why it has a par. On top of it, then we have L is variable. So you can see in the x-axis, we only indicated labor. We have no where we have captured capital. Hope you can see that clearly. So we have captured labor because in the short run, we are saying labor is variable. We have said labor is variable in the short run. That's one. Then number two, let us talk about another type of, we have what we call number two, the average physical, product. In some books, you are going to get it indicated as APP. The average physical curve. So we can define it and say it is let us use it right, let us capture it right. The average I'm saying the average physical product, of an input, is the total product, divided by that input used in the production process. I'm going to use the presentation area to illustrate that. So we are talking about, for example, in this case, we are considering labor. So the average physical product of labor is indicated in that is the total product. Total product we have said is Q divided by labor that you are dividing by. So for our case, we have said our function is given, Q is a function of K per L. So it is this thing you divide by L. So this gives us the average physical product of labor. It is the total product Q you divide by L. And it can be illustrated graphically in this manner. In this manner, we will be having labor. We have labor in the y-axis. We have labor. And here we are going to have average physical product of labor. So that graph is normally that way. It is normally that way. the average physical product curve is normally that way. That is the average physical product curve. Then we can talk about number 3, the marginal physical product, the marginal physical product curve, the marginal physical product curve. In some books, you are going to find it indicated as MPP. And we can say it is the change in total product resulting from a change in the variable input. We're talking about it is the change in total product resulting from a change in the variable input, and that one can be illustrated in symbol terms. We're talking about, in this case, we are talking about our case, we are considering LEPA as the variable input because we said in the short run capital is fixed. So when we are talking about marginal physical product of LEPA, we are talking about change in Q with respect to change in LEPA, and this one can be the change in the total product curve. We have K, that's a power on top, then we are talking about L, then you are dividing these with respect to change in LEPA. So this gives us the marginal physical product. This is F. So it can be drawn down and it can be given in that format. We talk about LEPA. And here we are going to have M, P, PL. We are going to have our origin. Then we are going to have our marginal physical product curve. It's going to be going that way. It goes to a certain point, then it comes 0. It is not clear the way I wanted it to be. It's supposed to be smooth. It comes to 0, then it goes to negative. So this is our marginal physical product curve. It starts from 0, it rises, then it declines back to 0. It declines back to 0. It declines back to 0. To capture something so important, we need to bring the 3 curves together, combining the curves. We have to try and combine all these 3 curves. So I'm going to trying to combine the curves, assuming that that is our y-axis and this is our x-axis. Let me try to be straight. In the x-axis, we have what we call LEPA. In the y-axis, we are going to have the total product, comma, we are going to have the marginal physical product, and here it is for labor, and then we are going to have the average physical product, and here we are talking about labor. Our curve has an origin, so we are going to draw the first curve we draw is we are going to draw that of the total product curve. Then we are going to call it total product. Hope you'll be able to label your graphs well. Then we will be having, we try to find a position where it is optimal at this point, and another position we can capture at this point, and we can elongate this above that way. Then we will be having another curve coming from the origin. Up to that point, it goes as it comes to a 0 at this point. We call it, make sure you draw yours well, don't follow. I'm trying to fix mine because this mother computer is not, it's not our thing. So we are talking about marginal physical product curve. Then what we do, we have another one. It comes from that point. It comes from that point, but for it doesn't, not that way. It rises, then what? We will have it going that way, that way, that way. It reaches the maximum, then it starts to decline, but it doesn't come to 0. It's declining, but that can't come to 0. We call it the A. We call it the average physical product curve. So here we are going to have 1. Here we are going to have 2. And here we are going to have 3. We have all these graphs. Hope you have indicated these as average physical product of labor, marginal physical product of labor, and here we have the total product curve. Are we together up to that point? Are we together up to that point? Anybody with a question? If you have a question, be free to ask. If you have any question, be free to ask. If you have any question, be free to ask, because we are trying to combine those graphs. Assuming that there's no question, let us talk about the relationship between the total product, the relationship between the total product, the relationship between the total product and the marginal physical product. The marginal physical product. We are talking about the relationship between the total product curve, and so we are comparing these two curves, this curve and this other one. So our curves of interest is this one and this one. So they are our curves of interest. So number one, what we see here, as long as the marginal fiscal product is rising, the total product curve will also be rising. So that is first thing we notice. We can say number one, as long as the marginal fiscal product of labor is rising, the total product will be rising. That's what we notice. These two curves at this point, when we can trace the marginal fiscal product is rising up to this point. Also, we can trace and realize that this total product is also rising during the period. When the marginal fiscal product is rising, the total product curve is also rising. That is one thing we can note. That is one thing you can note. Number two, we can say when the marginal fiscal product reaches zero, when the marginal fiscal product reaches zero, the total product reaches its maximum. So this is what I'm talking about. I'm saying at this point, when the marginal product reaches zero, tracing this line, we assume that the total product has reached its maximum when the marginal fiscal product is at zero. So when we have MPP equals to zero, the total product should be at the maximum. The total product should be at the maximum. The total product should be at the optimal level when this one touches that position 0. Then we can say number 3, when MPP becomes negative, when MPP becomes negative, the total product is declining. The total product is declining. So this is what we are saying. When this starts becoming negative at this region, we see that this also starts to go downwards. So there is a declining as MPPL goes to negative. There is a declining as it goes to negative. Then we can say, a note and say, an NB and say, a note NB and say, we can say the total product curve exhibits the total product curve exhibits the law of diminishing. It exhibits the law of diminishing returns. It exhibits the row of diminishing returns, and the row states that, a small amount of variable input is added to a given amount of fixed input initially output may increase. Initially output may increase at an increasing rate. Initially output may increase at increasing rate, but beyond certain levels of output, the rate of increase of total output diminishes. So this is what we are trying to talk about. Initially, there is this rate here. This is whereby when you increase input, output increases at an increasing rate. Then at this point here, when you increase input, output increases at a diminishing rate. Then at this point, when you increase input, output doesn't increase, it declines instead. It declines instead. So let us also talk about the relationship between marginal physical product and average physical product. The relationship between marginal physical product and average physical product So we are comparing, in this case now, in this case, we are going to compare these two curves, this one and this one. You can note that initially this one was above, then it came below, then this was from below, it rises, then it maintains below. So what do we say? Number one, Number one, we can say, number one, when APP is rising, MPPL is above. When APP is rising, MPP is above the APP. Hope you can see that. When we have this one rising at this point, the MPP is above. The MPP is above. Then number two, when MPP equals APP, APP is at its maximum. That one can be noted. This is the turning point. Where they meet, at this point where they meet, it becomes a turning point for the APP. So it is at the maximum. Then finally, when we say number three, when APP is declining, then MPP is below the APP. That's what we can see. When it starts to decline, the MPPL is below it. So that's what we can see from that illustration. That's what we can see from that illustration. That is what we can see from that illustration. That's what we can see from that illustration. Anybody with a question? Anybody with a question? Anybody who needs a clarification? Anybody who needs a clarification? If there is nobody who needs a clarification, let us talk about these stages of production. So we have this is stage 1, stage 2, and stage 3. So the stages of production, we are talking about the stages of production. Let us talk about stage 1. We have stage 1. When I talk about stage 1, I mean from this point to this point. This is where we have stage 1. This is our stage 1. This is our stage 2. And here we have stage 3. We have stage 1, stage 2, and stage 3 of production. We can say it is the stage of increasing returns. It is the stage of increasing returns. It is the stage of increasing returns. As input increase, output increases at an increasing rate. Output increases at an increasing rate. The farm has room to improve. The farm has room to improve its output. When it's operating at the stage 1, it has room to improve its output. Then we talk about stage 2. Stage 2, and they can say this is the stage. This is the stage of diminishing returns. This is the stage of diminishing returns. You can say when input increase, output increase, although at a diminishing rate. And we can say farms are at optimal utilization of resources. Farms are at optimal utilization of resources. Therefore, farms should operate at this stage. Farms should operate at this stage. So my dear brothers and sisters, let one day somebody come on board and give you a question like this. It was discovered that the textile industry was operating at the second stage of production. As an economist, explain why. So when you are brought a point into that case, you have been told the textile industry was operating at the second stage. I will want to see somebody illustrating all this, showing that at the second stage, it is the stage of diminishing returns. The farms are utilizing their resources. So it is that's why it was operating at that stage. So when you are given such a question and you find that you have been given more marks, such as 5, 7, 10, you need to be so careful. Don't just give the answer because somebody expects you to come up with this graph. Then you are going to explain at the second stage, there is a diminishing return. It is the stage of diminishing return. The farms are utilizing their resources and the farms are advised to operate at this stage. Okay, then let us talk about stage 3. Stage number 3. We can say it is the stage. It's the stage of declining. It's the stage of declining returns. As more inputs are added, output declines. So it is illogical. It is illogical for farms to operate at this stage. illogical. How can you be employing more input while you are making arrows? So you cannot be operating at this stage. You cannot be operating at this stage. So I want to give you a 5 minutes break. You can stroll out. Anybody with a question, you can post the question. Let us come back at 3:40. We do something little, then we call it a day. Okay, so we are back. Hope everyone is back. So let us talk about another subtopic, isoquant analysis. Isoquant analysis. Are we back? Let me check. Are we here? Are we back? So let us talk about isoquant analysis. We're talking about an isoquant analysis. So we can start by saying in the short run, we assume two factors of production. We assume two factors of production where one is treated as a variable input, while the other is treated as a fixed input. So here we are talking about the same thing we had before, where we talked about Q. Output is a function of K, whereby we said K is fixed and we have LEPA, which is variable. So we are talking about in the short run, we assume that. In the short run, this is what we assume. However, in the long run, all inputs are treated as variable inputs. So the topic we had is isoquant analysis. So the first question I posed to you, what is an isoquant? Somebody to tell me what is an isoquant using the public chat, because I defined an isoquant somewhere. What is an isoquant? I don't want to call anybody by name. I want to see people type what is an isoquant. I don't have one student. I have 9 students on board. Kuna mtu amekopi. Kuna watu wamekopi. Nimewaona. I have seen them. I've seen those people who have been copying. Collins, your answer is wrong. Collins, your answer cannot pass the exam board. It must contain something technology. So if you have not captured technology, your answer is automatically wrong. Guys, we don't have time. Just define that first so that we can continue. Habib, come on. You are leading so far. Okay. The consumer behavior was scrubbed off the syllabus for our case. It's not, they are much related. Indifference curves and isoquants are much related. So we have the theory of the firm and the theory of a consumer. Those are two different things. So I can think that you can define what is an isoquant up to that, right? So for me, I want to illustrate an isoquant. I want to illustrate an isoquant using, and to illustrate an isoquant. So an isoquant is drawn this way. I'm giving an illustration for the isoquant. So here we will be having K, and here we will be having L. Now, when we are drawing that using K and L, we assume it is a wrong turn analysis. Now that K can be moved and L can be moved. So we assume that it is a wrong term analysis. So we can say, in short, an isoquant is a wrong run analysis when all factors of production are variable. But all factors of production are variable. So we can have our isoquant, it is downward sloping. This is our isoquant. It is downward sloping like the demand curve, and that is our isoquant. That is our isoquant. It is downward sloping, and that is our isoquant. It is our isoquant. It is drawn that way. Then we can say the gradient in bracket slope of an isoquant the marginal rate of technical substitution. Bracket MRTS. The slope of the gradient of an isoquant is the marginal rate of technical substitution. And we can say it shows the amount of one input, the amount of one input that a firm needs to give up so that it can increase. It can increase another of its inputs. So for example, I want you to look at this graph we have on board. Assuming we were at this point, so the firm wants to increase, maybe probably the firm wants to use more labor. So the firm wants to use more labor, let us say at this point as compared to capital. So the firm will interchange. The firm will reduce capital to that point and increase labor to that point. That's why we are saying the marginal rate of technical substitution, the slope of the isoquant, is going to show us how much the firm is going to give up over one factor of production and increase one factor of production. So you are going to see that capital is going to reduce by this amount as labor increases by this amount. So that's what we talk about, the marginal rate of technical substitution. Are we together up to that point? Are we together? Guys, are we together? You know, if you don't participate in this class, I normally go to the register, I don't mark you in. Collins, where am I too fast? Where are you, Rost? I've been talking about isoquants. I said isoquants. In the short run, we assume that one factor of production is fixed, another one is variable. Then I said an isoquant is a long-term analysis whereby all the factors of production are variable. Then I added and said I drew the isoquant, it is downward sloping. I had capital in the y-axis and labor in the x-axis. Assuming that they are variable, you can reduce capital and you can increase labor, you can reduce labor and increase capital. Then I said the marginal rate of technical substitution is the slope or the gradient of this curve. It shows the amount of one input you can reduce and increase the other. Call this, where am I so fast? That's what I have covered. Ama niliwaambia muende kutafuta what is an isoquant mkaenda milele. Collins, am I too fast? I'm worried. Okay. Let me talk about the shapes of isoquants. Shapes of isoquants. Shapes of isoquants. Shapes of isoquants. We have different shapes of isoquants. Number one, we have a linear isoquant. We call it linear isoquant. We have a linear isoquant. And that shape of a linear isoquant, I'm going to show it here. Linear isoquants are drawn in this way. A linear isoquant. A linear isoquant is a straight line. This is a straight line that connects the two. We have capital here. We have flipper. Please make sure your graph captures bigger space, not mine. But also I can draw another one to show that it is a straight line. It is a straight line that captures the two ends, a linear isoquant. And we can note and say, it is for input. It is for inputs that are perfect substitutes. It is for inputs that are perfect substitutes. When we say an input is a perfect substitute, we mean that when we reduce one input by 2 units, we increase the other input by 2 units to maintain the same level of output. So when we are talking about perfect substitute, we mean that if we reduce something by 10, you increase the other by 10. So those are what we refer to as perfect substitutes. Okay, that is one. Then number two, another shape of an isoquant, we can talk about Leontief. Leontief isoquant. Leontief isoquant. I'm going to illustrate the Leontief isoquant. There are people who are coming on board now. I'm worried about them. I'm seeing some people, their names are popping up now. So we are talking about the Leontief isoquant. It is this way. It is illustrated in this form. A Leontief isoquant. We have capital and we have leper in the y-axis. Then the Leontief isoquant is L-shaped. It is L-shaped. This is our isoquant. And then we can say we can define and say it is L-shaped. It is L-shaped. And it means one input cannot, mark the word, cannot be substituted with another. One input cannot be substituted with another input. The inputs are complements. The inputs are complements. The inputs are complements. The inputs are complements. The inputs under consideration are complements. Jesus. The inputs under consideration are complements. Okay. Then we talk about the last shape, number 3. We talk about what we call smooth convex isoquant. Smooth convex isoquant. And that one can be drawn in symbol term. We can have them. We are talking about smooth convex isoquants. Smooth convex isoquant, we have K. We have our origin. We have our L. This is our isoquant. This is our isoquant. We can say it assumes that factors of production are continuously substitutable. The factors of production are continuously substitutable. That's what it assumes. They assume that factors of production are continuously substitutable. Last but not least, the last part we are going to talk about is the characteristics of isoquants. Characteristics of isoquants. Characteristics of isoquants. Number 1, they are downward sloping. They are downward, they are downward sloping. That is number one characteristic. Number two, isoquants. Isoquants do not intersect. You cannot draw isoquants in such a manner. When we mean that isoquants do not intersect, you should not draw isoquants in such a manner. Isoquants are supposed to be downward sloping in that manner. They are parallel to each other, they don't meet. If you draw an isoquant this way, and they are intersecting at that point, these are not isoquants. Isoquants do not intersect. Isoquants do not intersect. Isoquants do not intersect. Number three, superior isoquants, superior isoquants are far away from the origin. Superior isoquants are far away from the origin. For example, if this was A and maybe this was D, we say that D is superior compared to A. D is superior compared to A. It is far away from the origin, so it is superior compared to A. That's what we call the far isoquants from the origin, the more superior they are. Then finally, number four, isoquants are convex to the origin. They are convex to the origin. We know the difference. When you talk about convex and concave, we have, when we talk about, we have the origin, then we happen that we have a curve that is this is concave. And when we have this is convex. So isoquants are convex to the origin. This is concave. While this one is convex. So they are convex to the origin. They are convex to the origin. Up to that point, I want to leave something behind for you. I want to request you, number one, go and read about characteristics of, number one, you read about characteristics of LEPA. Number two, you read characteristics of capital. Number three, you read characteristics of RAND. And finally, characteristics of entrepreneurship. You go read about the characteristics of factors of production. You go read about the characteristics of capital, RAND, and entrepreneurship. Anybody with a question up to that point?